Hello everyone, this is Philipp Jonas for Kalamazoo Valley Community College, and today we're going to discuss elasticity and its application. Now that you're a little bit familiar with the model of supply and demand, you've probably noticed that how an equilibrium changes when you shift a supply or demand curve is affected by the shape of those supply and demand curves, how relatively steep or flat they are. Now, normally if I were to ask you, let's describe the shape, the steepness of a curve, you'd probably think of the slope of that curve as a good description. And for many purposes it is. But in economics, we prefer to use a related measure called elasticity. It's very similar to slope, but instead of looking at the absolute changes in the y and x-axis variables, the rise over the run, we are going to be looking at percentage changes in those two variables. There's a total of 4 elasticities we're going to discuss today. The first of them is the price elasticity of demand, and loosely speaking, it reveals how price sensitive consumers are. So let's start with a very simple example. Let's say you own a small business where you sell website design services. And here's what you've discovered. If you raise the price of your services by 10%, you sell 15% fewer units. So looking at these percentages and the formula for the price elasticity of demand, percentage change of quantity demanded divided by percentage change of price, let's go ahead and plug that in. 15% divided by 10% is the number 1.5. Notice the percent cancel, so this is simply the number 1.5, not 1.5% or something along those lines. Now you might be wondering, shouldn't that be negative 1.5? Since one of these variables is decreasing the quantity and negative percentage change. And ordinarily, in the mathematical sense, you'd be absolutely right. But we have a convention in economics. Since when it comes to the law of demand, we should always expect price and quantity to move in opposite directions, we would always receive a negative number for the elasticity. So the convention that developed is that price elasticities of demand are always reported as a positive number. This is a little bit unfortunate when you first learn about elasticities, because out of the 4 elasticities we learn about today, the last 2 can be positive or negative, and the sign matters a great deal, so you'll have to track the signs on those percentage changes. We'll get to those later. Let's go ahead and talk about percentage changes themselves a little bit. Usually you won't be provided with what the percentage change in quantity and price are. So let's retool this example a little bit. Let's instead say that when you raise the price of your website from $200 to $250, the number of units you sell falls from 12 to 8. Now let's calculate these percentage changes manually. You're probably thinking of the standard method for calculating a percentage change right now. Here it is for your reference. You take the difference between two numbers and divide it by the start value. And then, depending on how you were taught about converting to a percent, you might have been taught to multiply by the number 100%. So let's go ahead and apply that to the price of your website. The price is increasing from $200 to $250. So 250 minus 200, the numerator of this fraction is $50. That's the change. The denominator of the fraction is the start value. That was 200. In other words, taking $50 and dividing it by $200 after converting to a percentage representation, you would say that the price of the website has increased 25%. Now the reason we're talking about that is that when it comes to elasticities, economists don't use the standard method of computing a percentage change. It has a weakness that's quite severe when it comes to this application. Let me explain. I decided that the start price on this demand curve was 200 based on these arbitrary labels A and B that I had placed. But demand curves don't have a start or an end. A different economist might look at that same curve, place different labels, perhaps consider $250 its start value. And then they're going to compute a different percentage change, because the standard method of calculating percentage changes is sensitive to the start value. Let's go ahead and compare. So economist A chooses A as the starting point. Let's look at their calculation for elasticity. For price, they calculated 25% increase. We just did that. And for quantity, well, let's look at the numbers. The difference is 4. The start value is 12. So that'd be 4 divided by 12. That's a third of 33%. Economist B chooses B as the start point. So let's look at the price. It's still a $50 change, but economist B divides by 250 as the start value. That's a 20% change. Economist B, looking at the quantity, goes from 8 to 12. That's still a 4-unit change, but they choose 8 as their start value. So that would be a 50% increase. Look at the impact this has on the elasticity calculation. Economist A calculates an elasticity of 1.33. Economist B, almost twice as much, 2.5. That's unacceptable. We can't have different economists looking at the same curve, make different decisions about where it starts, and come up with completely different measurements. So instead of the standard method of computing percentage changes, in economics we use a different method for calculating elasticities. And you might be able to guess where this is going. The difference in these numbers came from only one place, choosing the start value. So what if we calculate a percentage change in such a fashion that there is no start value? What if we divide by a base that does not change no matter how you look at this curve? So let's look at the price. Let's not use 200 or 250 as the start. Instead, we will divide by the middle, because the middle of two numbers doesn't change. This is called the midpoint method. Let's look at price as an example. So we're looking at the difference, 250 and 200, same as always. But instead of dividing by either one of those numbers, we divide by the middle. The middle between 250 and 200, of course, being 225. Let's do it again for quantity. So for the quantities, we had 8 and 12. The difference is 4, but we're dividing by the middle being 10, right in between 12 and 8. That gives us a 40% change. So where you might remember a traditional percentage change calculation as difference over start, the midpoint method is difference over middle. Finally, of course, every time you're calculating an elasticity, after you've calculated two percentage changes, you do have to divide them by one another. In general, we're going to be talking about 4 types of elasticities today. All of them follow a common pattern. Every time you calculate an elasticity, you are dividing the percentage change in quantity by the percentage change in something else that's causing that change in quantity. So for all 4 of our elasticities, the percentage change in quantity always goes in the numerator. If you remember that, you won't make a mistake for any of those. Let's go ahead and give you an opportunity to practice the math here and calculate one more elasticity. Let's say you're managing a hotel. Now, you know about this hotel that if you charge $70 a night, you'll have 5,000 bookings for the month. But if you charge $90 a night, you will have 3,000 bookings a month. Based on these numbers, go ahead and calculate the percentage change in the price, the percentage change in the quantity, and armed with those 2 percentage changes, calculate the elasticity. Go ahead and pause the video and then continue once you've got your numbers. All right, so let's go ahead and see how we can solve this correctly. First, let's focus on the percentage change in quantity. The numbers we're looking at are 5,000 and 3,000. The difference between them is 2,000. The middle is 4,000. 2,000 divided by 4,000, that's a 50% change. Next, let's look at the price. The numbers we're looking at are 90 and 70. The difference is 20. The middle is 80. 20 over 80 is a 25% change. Now notice I was inconsistent in what I used as my start points here. I started with the high level of customers, the 5,000 in the quantity calculation, and the high price, $90 in the price calculation. That's because I know that for a price elasticity of demand, we'll always report it as a positive number, so I don't have to worry about tracking the sign. For our final two elasticities today, we'll have to be more careful and pay attention to the sign. Let's go ahead and finish up by calculating the elasticity. Always the percent change in quantity in the numerator. So 50% over 25%, we'd say the elasticity is the number 2. The meaning of this is that for every 1% we're changing our price, the number of bookings we have changes by 2%. We're going to discuss the meaning of elasticity in greater detail now. Let's start out with some examples that will also be useful lessons for what sort of numbers you should expect when it comes to elasticities. First example. Let's say you've got a company that sells 2 products, insulin and Caribbean cruises. It's a very interesting company. Now, for some reason, you decide to raise prices across the board by 20%. Obviously, you'll lose some customers. But where are our customers going to cut back more? This is very predictable. Insulin is a necessity for millions of diabetics. Yes, price has an impact on how much is bought, but it will be a very small impact because people need insulin. Caribbean cruises are an example of a luxury. Here, when price rises, it is much easier for customers to cut back on how much they buy. So when calculating the elasticities, in the denominator we have a 20% price change for both, but in the numerator, Caribbean cruises would have a greater quantity change, leading to a higher number for the elasticity. This is a lesson that holds in general. Luxuries have higher elasticities than necessities. There are useful results we're going to derive from this observation. There's a second lesson when it comes to the numbers you should expect for elasticities, but this one is much harder to guess. Let me tell you about it. It's about time frame. Let's say the price of a product, gasoline for example, goes up 20% again, and let's say it stays up. So this is not about whether people expect the price to rise further or what will happen in the future, just a one-time permanent 20% increase in price. When will people change their quantity more? In the short run, let's define that as the remainder of this semester, or the long run. Let's define that as 2 years in the future. Well, the correct answer is people will change their quantity more in the long run. Let me explain. If I want to make an estimate of how much gas you buy in a given week, a few things I'd need to know about you to have a pretty good idea. Where do you live? Where do you go to school? Where do you work? What kind of car do you drive? Between those 4, that's most of your gasoline consumption. Now the thing is, if gas gets more expensive, this semester in the short run, it's very hard for you to change any of those. You'll probably not sell your car because of it. You'll probably not move because of it. I hope you're not going to drop out of KVCC. So what's left? If you want to cut your gas consumption, you would have to perhaps carpool with some of your friends, or perhaps ride the bus. But let's be serious. it's much more likely that you'll complain about the higher gas prices and keep buying the same amount. Now, let's look into the future. 2 years from now, you're going to be changing some of those prime determinants of your gasoline consumption anyway. You'll probably be moving to a new apartment anyway. I hope you'll have graduated from KVCC by then. And when it comes to choosing your next job, where it is might have a greater impact on your decision in the face of higher gas prices. In the long run, you always have more options to change your behavior than in the short run. And since elasticity describes how you change a behavior, your quantity demanded, your response will always be a bigger number the more time passes. This phenomenon is particularly strong when it comes to gas prices, that's why they're a great example, but it holds true in general across all product types. So armed with these general 2 lessons, let me also tell you a little bit about the vocabulary we use to describe whether an elasticity is a big number or a small number. And basically the critical number it comes down to is the number 1. If elasticity is less than the number 1, we consider it to be low. Specifically, we call that inelastic. Let's start with a very extreme case of inelastic. How low can an elasticity go? Well, if we think about a demand curve that is vertical, here we have a price change, let's say 10% for an example, and the resulting quantity change is nothing. Our customers are absolutely dependent on the product and will continue to buy the same amount at any price. So looking at the calculation, our elasticity will be the number 0. And in terms of the vocabulary, this extreme version of inelastic we call perfectly inelastic. In general, inelastic refers to any elasticity less than 1. So how do you get an elasticity less than 1? Well, if you have a given price change, let's stick with 10%, that fraction is going to produce a number less than 1 if the numerator is less than the denominator. So in this example, less than a 10% change. This is inelastic. We refer to demand as being elastic if it's more than 1. But before we get to that side, there's even a special vocabulary term if the elasticity lands right on that breakpoint, right on the number 1. If the price and quantity percentage changes are equal, if the elasticity is exactly the number 1, that's referred to as unit elastic. Now that might seem like a very special case, and it is, but there are problems in economics to which the solution is an elasticity equal to the number 1. So that's why it has its own name. Starting at numbers greater than 1. So again, here a price change gives us a quantity change that's greater than the underlying price change. We are looking at elastic demand curves with an elasticity greater than 1. Notice that as we increase the elasticity, the demand curve becomes flatter. We started with a vertical demand curve, and now we're making it more and more horizontal, all the way to the opposite extreme. If a demand curve is all the way horizontal, then we are looking at no price change making any quantity possible. Or if it's easier for you to think of, we're looking at if you raise price even a little bit, quantity immediately goes to 0. Now, you of course know that when it comes to building a fraction, you can't divide by 0. This result would be undefined. But I'm now going to tell you something unusual. I will instead refer to a perfectly elastic demand curve as having an elasticity that's infinity. Even though that's not at all right in terms of the math that I'm showing you, it's the language that professional economists would use. When professional economists calculate elasticity, they use a slightly different method than percentage changes, a technique from calculus called differentials. And using that technique, as the demand curve goes to the horizontal, the elasticity does approach infinity. So even though our math doesn't properly produce that result, I want you to know what economists are talking about when they are referring to an infinite elasticity. So this is the price elasticity of demand, how to calculate it, and how we talk about its results. Let's do two applications of this concept before we move on to our other elasticities. And before we get to our first application, let me give you one small warning. I often like to refer to elasticity as a concept that's closely related to slope. And that's correct, but it can mislead you in one way. Look at this demand curve, a nice straight line. Now you know that if I were to ask you to measure the slope of this line, it wouldn't matter where you do it. Straight lines, by their definition, have a constant slope. But its elasticity, that varies greatly along this straight line. Here are some sample numbers you can check for yourself if you want to check my math. Along this curve, the elasticity varies greatly. So if you have to solve a problem where you're calculating the elasticity between 2 points, you have to calculate it between exactly those 2 points. Let's get to our first application. Elasticity will be with us for the rest of the semester. But a particularly obvious application is that the price elasticity of demand is related to the revenue of a product. Revenue, let me be clear. So we're talking about the sales of a business, its turnover, not the profit. We'll also talk about profit, but profit is revenue minus cost. Right now we're just focusing on the revenue side. The price of your product times the quantity sold. I want to show you something. If you're selling an elastic product, so remember, that means the elasticity is greater than the number 1. Or looking at the fraction, the percentage change in quantity is greater than the percentage change in price. If you're selling an elastic product, raising price will reduce revenue. That's because when you raise price, you will lose unit sales faster than you can increase price. And to show you that, I want to go back to our website example from the beginning of today. So once we calculated the elasticity of this website business properly using the midpoint method, it turned out to be 1.8. And let's review the numbers behind that. The initial price and quantity were $200 and 12 websites. That of course means the revenue of this business would be $2,400, 12 times 200. That's just arithmetic. But let me show you another way of representing this revenue. Do you see this area I've highlighted in blue over here? That area is of course a rectangle. And as you know, you can calculate the area of a rectangle as its base times its height. So this rectangle, it has a base of 12, 0 to 12, a height of 200, 0 to 200. If we calculate the area of that rectangle, it's the revenue of the business. Revenue has a geometric representation when we look at a demand curve. You can think of it as a rectangle formed by the point on the demand curve, the price-quantity combination we're at, over to the y-axis and the x-axis. Now, why in the world would we ever do that? Think about revenue geometrically. Turns out in economics, we do this very frequently. There are many concepts we'll think about geometrically because it makes it much easier to visualize changes. Let me show you. The second price-quantity combination for our website business was, if we raise the price to $250, we now sell 8 of them. So the revenue here will be $2,000. But let's look at this in terms of the geometry. The original rectangle is the area highlighted in blue. The new rectangle, the area highlighted in yellow. you can see how your revenue changes as you raise price. First, there's an area in blue on the right that you lose when you raise price. Let's highlight that. This represents people who are no longer buying your product. When you raise price, you're losing 4 customers. Each of them used to give you $200. That's the size of that rectangle shaded in blue. 4 times 200. Its area, 4 times 200, $800, is the loss in revenue from customers who stop buying your product. But that's not the only change in your revenue. Look up here. We have a brand new area. This rectangle has a size of 8 units wide, $50 tall. And it represents the fact that when you raise price, those customers that stay with you, you now earn more revenue from them. Specifically, 8 customers are staying with you, each of whom is paying you $50 more. 8 times 50, that's $400 in additional revenue from existing customers. Let's net those two effects out. We're losing $800 in revenue from the 4 customers that leave us. We're gaining $400 in revenue from the 8 customers that stick with us. The net effect is that our revenue drops by $400 from the original $2,400 to the new $2,000. This happens every time you're looking at an elastic demand curve. Anytime the elasticity is greater than 1, the fall in revenue when you raise prices from losing quantity will be greater than the increase in revenue from higher prices on existing customers. The net effect will always be negative. Let's look at this a second time. Let's do another example, but this time for an inelastic demand curve. So of course, inelastic means the elasticity is a number less than 1. Or looking at the fraction, the percent change in quantity is smaller than the percent change in price. So I don't want to do a completely new example here, but to show you that revenue increases when you raise price on an inelastic product, let's make a small modification to the website example. Let's say, keeping all the other numbers the same, when you raise the price to $250, quantity falls to 10 units instead of all the way to 8. So you're losing only 2 sales instead of 4. This changes the elasticity. If you want to, pause the video and give it a shot calculating yourself. The new elasticity is the number 0.82. So let's look at our revenue here. The initial set of numbers is the same as before. $200 per website, 12 units sold, $2,400 of revenue. Now let's raise that price to $250. Here's the new number. When we go to 250, our quantity is 10 instead of falling all the way to 8. So you can already tell that our revenue has increased here. But let's focus on the mechanics of change. When we raise the price, this time we are losing only 2 customers. So 2 customers who used to pay us $200, that's $400 lost. And now let's look at the gain. It's bigger. We get 50 additional dollars from 10 units that are still being sold. 10 times 50, that's $500. We lose 400, we gain 500. Netting it out, that's a positive $100 for our revenue when we raise price. This happens every time demand is inelastic. If the price of an inelastic product increases, revenue increases along with it. This is our first application of the principle of elasticity. There's another one that's less business-oriented and more social policy oriented. And it's an example that as an economist, you are more or less required to talk about when first introducing elasticity, because it's such a good example. Let's go ahead and talk about the market for drugs, not pharmaceuticals, illegal addictive drugs. Now, they are a great example of price elasticity of demand because think about it for a second. How do you think the price elasticity of demand for an addictive drug looks? It's addictive. Even if prices rise, quantity doesn't change very much. Addictive drugs have a famously low elasticity of demand. And because of that, we can make a very interesting prediction. You see, as a society, we often want to reduce how many addictive drugs people consume. That's why we make them illegal. And there are many reasons for that. Not just the health of the drug users, but also that when it comes to affording these drug habits, when it comes to the revenue spent on illegal addictive drugs, there's a lot of crime that finances that revenue. So let's go ahead and draw in the rectangle that represents the revenue in this illegal drug market. Price times quantity, there's our rectangle. And let's treat that as a proxy for the amount of crime that's being generated. Now let's ask ourselves, what happens if we try to fight drug use by targeting exclusively the supply of drugs? We've already learned that if you reduce the supply of a product, its supply curve shifts to the left. You already know if the supply of a product shifts to the left, price will increase, quantity will decrease. But now you have a new tool, elasticity. If the demand curve is very inelastic, like in this example, you know that the increase in price is going to be much bigger than the decrease in quantity. Or in other words, tying back to our previous example, you know that when the price of a product that has an inelastic demand curve increases, revenue increases. And that is a classic example of a policy that has both an intended and an unintended consequence. So the intention of reducing the supply of drugs is to reduce drug use. Let's look at the quantity axis. Indeed, we have less drug use. The intended outcome is achieved. But there's also an unintended outcome. The more we reduce the supply of the drug, the more revenue will be spent on these drugs, resulting in perhaps more drug-related crimes. This is a key lesson of economics. When you implement a policy, it doesn't just do what you want it to do, but it almost always also has consequences that are unintended. So let's look at another approach. What if we could develop an education method that would reduce the demand for drugs? Yes, I know this is a little pie in the sky, but stick with me for the example that I want to show you about the math here. If we could reduce the demand for drugs, we are reducing both the price and the quantity. So looking at the revenue, it would now fall because we're making that rectangle smaller from both directions. That's our final example of how we can use the price elasticity of demand today, but we will use it a lot more in the future. Now let me tell you about the other three elasticities we'll be learning about today. They all follow the same pattern. How does a quantity change in response to another variable? Let's start with the price elasticity of supply. Just like for a demand curve, you can calculate an elasticity for a supply curve. So we're looking at when the price of a product changes, how much more or less do the sellers want to sell? For example, let's say the price of a product rises by 8%. As a consequence, sellers are willing to sell 16% more units. Plugging it into our standard elasticity formula, we would say the price elasticity of supply is 2. That's a positive number. That's always a positive number because of the law of supply. Price and quantity move in the same direction. We use the same terminology to describe the price elasticity of supply as well as we do on the demand side. But let me walk you through it and talk a little bit about where you might encounter these types of supply curves. We'll start on the very inelastic side, a perfectly inelastic supply curve, a vertical supply curve. Any price change, no change in the quantity supplied of the product. An elasticity equal to 0. So this is a product that you cannot change how much exists. You cannot make more of it. Very extreme, but it does happen. For example, let's say we're talking about the artwork of a dead artist, like Rembrandt paintings. It doesn't matter what happens to the price of Rembrandt paintings. No more of them will ever be made. That leads to a vertical supply curve. That, for example, is why the price of such artwork can vary wildly when the demand for it changes. All the demand changes the price. None of it changes the quantity. All right, so this is the extreme case. In general, when we've got an inelastic supply, so the percent quantity is less than the percent price, the number is less than the number 1. These are the products where it's hard to make more of them. We also have the concept of unit elastic on the supply side, elasticity being exactly equal to 1. And now let's go over to the elastic side. So that's where the elasticity is greater than 1. This is products where it's relatively easy to produce more. For most products, this is the case. And now let's go ahead and go to the absolute extreme. What if we lay that supply curve all the way flat? A perfectly elastic supply curve. So at the given price, any quantity can be sold. First of all, forgive me for once again saying that this is infinity. I know that in terms of the fraction it's not, but in terms of how economists use the language, since professional economists use slightly different math, I want you to understand what they're referring to. So this sort of product is perfectly easy to make more of. In fact, at the given price, any amount is available. Think of digital goods here as a fantastic example. If you go on an online music store, on iTunes, you buy a song for 99 cents. How many people can buy that song before iTunes runs out? Well, it's a ridiculous question. iTunes will never run out. It's just a copy they're selling you. They can sell an infinite amount at 99 cents. That's a perfectly elastic supply curve. And if you think about how many products in this day and age we buy that are at their core a copy, you realize how much more important perfectly elastic supply curves have become in our world. So to finish up our discussion of the price elasticity of supply, let me show you a very typical supply curve. So going away from copies, back to products that are actually manufactured, you will often find supply curves that have an increasingly upward slope, a convex shape. It's not a guarantee. This doesn't have to happen, but it is common enough that I want you to be aware of it. So here's what's going on. Many products, when their price increases, initially, how much is offered increases greatly. Elasticity is very high. That's because most products, if there's an increase in demand that drives price up, manufacturers can respond by quickly making more of the product. But many products have a limited capacity for production. For example, let's say a particular car becomes very attractive. People just start buying this car. At first, the car manufacturer can increase production easily by perhaps adding weekend shifts or adding third shifts. But eventually, the factories that are geared up to make this car are running at full capacity. Now, if the manufacturer wants to make more, they have to retool other factories. That's more costly. That means now price increases will result in much lower increases in the quantity supplied. Elasticity will fall when we hit this capacity limit. Of course, our general lesson holds. Elasticity increases across time. If demand stays high for a couple of years, the manufacturer can convert the plants, can maybe even build additional factories, and will have a much higher elasticity given enough time. But in the short run, many products do have a capacity limit that you bump up against. So these are the elasticities of supply and demand. Their sign doesn't matter. We'll always report it as a positive number. But there are two more elasticities. They have very specific use cases. And here, the sign is the most critical part. Let me tell you about them. Number one, sometimes we care about how the quantity demanded for a product changes, not because its price changes, but because the income of its customers changes. That should sound very familiar to you, right? We talked about income being a factor that affects the demand for a product. I'm of course talking about normal goods and inferior goods. We measure if a product is normal or inferior by looking at its income elasticity of demand. Meaning, we look at the percent change in quantity in response to a percent change in income. And here, the sign is everything. So, let me tell you how to get the sign correct here. You're still calculating the percentage changes using the midpoint method, just like you're used to. But when you're done, you sign them. You put a plus or minus sign in front of each percentage change, depending on if the number increased, that's a plus, or decreased, that's a minus. Simple as that. So here's what can happen. Option number one. If you are looking at a normal good, quantity will increase when demand increases. So you're going to have a positive number in both the numerator and the denominator. Or quantity will decrease when income decreases. You'll have a negative number in both the numerator and denominator. Either way, the value of the fraction is greater than 0. It'll be a positive fraction. That's a normal good. Normal goods have positive income elasticities. Inferior goods, they work the other way around. Inferior goods, when people have higher incomes, positive income change, we see lower quantities, negative quantity change. Or lower incomes lead to higher quantities. Either way, one of your percentage changes will be positive, one negative. That will give your fraction, your elasticity, a negative value overall. And that's how you recognize an inferior good. It has a negative income elasticity of demand. There's one more special use case elasticity that works like this. And you can probably think of what it is already. Because when we talked about supply and demand, there wasn't just one pair that affects the demand for a product, normal and inferior. There was another one, substitutes and complements, how the demand for a product responds to a price change in a related good. Here too we have an elasticity. It's called a cross-price elasticity. Cross-price means a price, but not the price of the product whose quantity we're looking at, the price of a different product. cross price. So when we're calculating this elasticity, it's the percent change in quantity of one product divided by the percent change in price of a different product. Again, you have to sign your percentage changes here because the relationship can be substitute or complement. Let's think about substitutes first. Let's talk about gasoline and electric vehicles. If gasoline becomes more expensive, positive price, we'll see a higher quantity demanded for electrics, positive quantity change. So a positive overall fraction. Or if gas gets cheaper, people buy fewer electric vehicles. Negative and negative, still a positive value for the fraction. For substitutes, the cross-price elasticity of demand will be a positive number. Conversely, let's think about complements. If gas gets more expensive, pickup truck sales will fall. Gas gets cheaper, pickup truck sales will rise. One of your percentage changes will be a positive number, the other a negative. That will give your fraction an overall negative value. And that's how you recognize a complement, a negative cross-price elasticity of demand. And that's our discussion of elasticity and its applications.